Hello, everyone. Come on in. Let's see here. Come on in, everyone. How are y'all doing?
Hello.
We are here. Looks like we got a full house, too. Oh, I did not mean to do that. Okay. We're just waiting for everybody to get in. I'm sorry I cut the time so short and just barely got in. Actually, I ended up getting in 3 minutes late. Apologize for that. I'm Mr. Younger. I'm teaching you physics this semester. I've been teaching physics, astronomy, and mathematics at the college level since roughly 1996. So 20 some years, 26 years maybe. This class is a calculus-based physics class. I hope you're in the right place. Obviously, I sent you the link through the email. There's also a link in our Canvas page as well. I'm in the process of getting connected with MyLab and mastering, but that's not going quite as well as I'd like, specifically because it appears Pearson's having some difficulties. So we're going to keep working on that as we can. But until then, and I suspect this will all be taken care of by tonight. But anyways, until then, you won't be able to see your homeworks. They will be, if you look in Canvas, which I'm getting ready to go over, they will be in your weekly modules. So this is week one. You'll see there's a week one module, and it says August 22nd to August to 11:59 p.m. or 11:55 p.m. on August 28th. That's generally how all the assignments work. We cover at a rate of about one chapter per week. And at the Sunday at 11:59 p.m., the homeworks for that chapter are due. So we usually cover it on 21, and then start covering it. In this case, it'd be chapter 1. We cover that immediately starting tonight, and then it's due at 11:59 p.m. on Sunday. And then next week we'll start chapter 2, same thing, so on. There's always at least 2 homework assignments. There's one that's called the chapter homework, and then there's one that's called the conceptual homework. And the conceptual count counts a lot less than the regular, but is still very important. And the regular stuff counts about 4 times more. I have a chat going. I don't see anybody putting anything to it, and that's cool because I'm still trying to figure out what's going on in the background on my computer. I made the syllabus and it won't save for some reason, so I'm going to have to show it to you in the Microsoft version of a HTML document. So I'll pull that up to show it to you. Let's go ahead and start off by doing share screen. I'm going to share screen right here with this one. So this is our Canvas page. If you look up here, it says TC295, PHY241, D02B. That's technically not supposed to be a D. That's supposed to be a N because this is a night, quote unquote, night class. So that should be hopefully changed to N01B, but they might choose to leave it. It's no big deal either way. But I just want to make sure you guys knew that was a possibility. So we're going to have that possibly change. If you'll see over here, there's a link that says MyLab and Mastering. That is a place you can always go to get to MyLab and Mastering. The main thing is I want you not to ever try to get to MyLab and Mastering by just going straight to the MyLab and Mastering website. You always want to go to Canvas first and then go to it, because if you manage to find a way to get into your MyLab and Mastering course that doesn't involve you going through Canvas, then I won't be able to see that score, and therefore you won't have a grade for that homework assignment. So make sure you always go this way. Let me go ahead and turn to the module section. So this is the requirements that basically every class has, is this top thing where I have basically an introduction to distance learning, Canvas support, Canvas orientation, Zoom support, student services, student handbook, all that good stuff, and the ability to purchase your stuff on Barnes and Noble's page. So that's always there. You don't use it too often. We will be using Respondus Lockdown Browser and Respondus Monitor this semester because as an internet class, this is fully internet and synchronous. We will have a comprehensive midterm and a final exam that you'll take where you're basically have your browser locked down and you're being recorded and watched. And the other tests will just be willy-nilly. And I'll explain those a little bit more when we get to the syllabus. So I'm going to kill this right now. This is where our Zoom stuff is. I don't know if you'll need to click that. Probably y'all were able to just click on the email I sent you. Did anybody get it to this Zoom meeting by clicking on the email I sent them? Nah. So some people did. Okay, that's cool. Those of you, any one of you that didn't go by clicking on the email, how'd you get there? Did you click on this link? Okay, I see one person click on it. So I know now of 2 ways for you to get to the link. Now, did you have to manually type in that passcode or was it already in for you? If you haven't.
I typed it in.
You typed it in? Okay, cool.
I typed it in too.
I suspect you won't have to next time. So, but we'll see. And you can let me know. That would be helpful. This will actually be where your syllabus is. And your syllabus is very important. So important that I got a video about how important your syllabus is. And I've tried to put your syllabus here, but like I said, it won't let me. So if I go here, click on file, and I actually had saved the syllabus as a .html file because that's the way they want us to do it. Let's see, there's 3 of them. Wow. Okay, let's see if this actually works. Add item. It keeps giving me an error when I try to put it up. This time it works. So maybe it's actually working. So let me click on it and we can talk about the syllabus. I'm feeling pretty good. Woohoo. Now you will notice I am a goofball and I try to make a lot of jokes, and I probably make about 100 jokes a class and like 3 of them are good, and y'all will laugh at them and you'll leave thinking I'm funny when I'm realizing that I'm like got a 3% success rate. So that's okay. Let's see what happens here. Oh, yep, it says 0 bytes. So yes, the file has been corrupted in some god awful way and I don't know how. So what I'm going to do instead is I'm going to stop share and then I'm going to start sharing with another page. So share screen. That one's not it. That one's not it. That one's not it. How can this not be it? Huh. I sort of can. Let's see. Maybe that's it. Okay, so I'm going to do, nope, not that one, this one. Okay, so this is a version of the syllabus that I'm currently working on, but it wouldn't save, so I couldn't do it the way I wanted to. Maybe is it this one? Let's see here. Nope, that's not it. So yeah, I made all these changes and it just completely ignored them. So this is still roughly the same thing as your syllabus. What I will tell you is that this right here should be a N, and this right here should be a NIGHT, and there should be no space there. This right here, I'm going to do file, save as. I'm going to change this to N. I don't know if y'all see that page or not, but it's just no big deal. We'll just do it, pretend like everything's working right. But maybe that worked or something. Yes, I want to consider that. Okay. I don't know why the F's there. Actually, I do know why it's there, but anyways. So what I'm trying to say in this top box is that basically, hey, this is my email address, wyoungger@tcc.edu. And when you email me, there's a high probability, if y'all looked at Rate My Professor, you'll find bad things about me in responding to emails. I would like to tell you they're not true, but they have been true. I've had a lot of problems with that, so I apologize. I have a way that has fixed it now. So I will explain the way. For one thing is when you put in your email, one, I want you to only email me from your TCC email account. Two, I want you to start your subject line with PHY241 space night. Okay. If your email starts with that, then I will immediately say, oh, these are the emails that are important to me, and I'll open them up. And I want to make sure I always reply to you within 2 working days. So worst case scenario, that means you could send it an email to me at 12:01 a.m. on Friday. And I need to get that back to you, worst case scenario, by 11:59 p.m. on Tuesday. That's what I mean by 2 working days. So it's actually a little bit bigger than that. I plan to get back to you within the same day. Okay. But if you ever go even to the point where it's something urgent and you need me and you don't need the 2 days thing, then I'm giving you another route. And that's this right here. If you see no response within 2 working days, or in the case of emergency, I want you to text me at this number. So this is my personal cell phone number, and you guys can text me at that if you ever try to email me and can't get up with me. I'm usually very responsive, usually respond within a couple hours, if not immediately, when you text me. But the main thing is, like, if you see me an email, please start the subject line with PHY241 space NIGHT, and then only email me from your TCC account. And 2, make sure you include your first and last name. I get a lot of emails like email from doodlebug@yahoo.com, and they say, hey, this is Sarah from your class. I got lots of classes. I got lots of Sarahs. I don't know who that is. So this is like a double layer of protection. But normally speaking, if you actually write the subject line properly, then that filters that I have for my email to block out all the crappy emails, that usually brings that one to the top so that I can find you. So it should all work out, in other words. Anybody have any questions about that? Boy, we got a lot of people in this class. Woo. Cool. Okay. So the class will not be meeting at this time. It will be meeting at, of course, 5:20. And I literally just changed this, but for some reason it didn't save. Maybe it'll work better now. 5:20 p.m. to 7:40 p.m. And it is meeting via Zoom. Oh, don't let me do that. Okay. My office phone number, and you need not bother using it. It's almost never that I answer it. I forget often even how to check the voicemail. So it's pretty much useless. The only time I'd really recommend you using that is like if you're coming in for a test, which you guys never do this in internet class, but if you can't get a Respondus lockdown browser and a webcam, then it very well might be the case that I'm going to have you take an online, or excuse me, a testing center. So if you had one scheduled, you can't make it, you might want to, because of a car wreck or traffic jam, you might want to call me on that number so you'll have a time-stamped voicemail message for me. That would be fine. Other than that, I wouldn't waste your time using it. Just send me an email, or if it's really urgent, you can text me, and that does the same thing, because obviously I get to know not only when you texted me, but what day, what time, and all that good stuff. So
I got a question, Professor.
Yes, go for it.
So on the SIS, it talked about this class going till 6:40, then the lab starts at 7:10. Is the lab a different time now?
Not that I know of, because I have another person teaching that actual lab. Let me pull that up real quick. I think I can do it if my system hasn't come down yet. It looks like
I emailed her and verified that we're actually going to be in person after this.
Yeah, for the lab would be it's starting at 7:10. I mean, that's what SIS says. I don't know.
Yeah, I think that's supposed to be right. The main reason is I wanted to give people plenty of time to finish class and then get to the actual campus. We're not trying ever to offer online labs again. We just did not find that was a very successful way for our students to learn. So we try not to do that now. But it does look like it should be almost a whole hour after. So I'll pull up to just see if any of that changed. I was able to do that, so that's kind of nice. And I'm doing a search now. And that's the Monday. Yes, it looks like it's 7:10 p.m. to 10 p.m.
Correct. You said that this class goes to 7:40.
Oh, I meant to say 6:40. That's okay. That's yeah, it's only 6:40, and I might even typed in 7:40 like an idiot because that happens. Did I type in? Yeah, I did type in 7:40. That was the problem. Thanks for catching me on that. That's the kind of thing that would be a pain in the butt. So yeah, the class is over at 6:40, and then you have till 7:10 to get to the lab. If y'all find that that's most helpful by doing going online within the building, that looks like a lot of you are on campus doing that. That's great. If you live close enough to do it at home, that's great too. The main thing is we're just not going to do any kind of online labs, so we're all going to always be face-to-face in labs. All right. Any other questions before I move on with syllabus? Thanks for that one, by the way, Jamie. I think that's what it was. So I do have
actually I have one thing, if you don't mind. Access codes for Pearson.
Gotcha.
That was the major stop.
So you're asking something about access codes. I don't know exactly what you asked, but what I will tell you is this, and I probably will answer your question by saying this. So you can buy the access code from the student store. You can buy it with just the e-text. It automatically comes with that, or you can buy it with a binder ready copy of the textbook. If you don't like reading electronic format books, then that's fine. That's the cheapest way to get the actual book that we are using. But if you don't care about that, then you can also just click on one of our homework assignments in Canvas, and it'll immediately ask you to make an account if you already don't have one. And then it'll give you a 2-week grace period, I think it is. Or you can go ahead and purchase the access code right there. And that's probably a little bit cheaper way of doing it. In other words, our student stores obviously are there in it for making some money, so they get to mark up the price. If you get it directly from the website, though, you might actually save a couple bucks.
Professor, I think he means the problem is that right now the access code isn't working.
Oh,
it's using like the course number or the invite in order to use it.
Okay.
For either the lab or the lecture, the two access codes associated to it are not functioning. Okay. And they posted something on the Pearson site regarding it. They said there was like a malfunction that they don't know when it's going to be fixed until.
Yeah, that's true. So I have been noticing that. That's part of the problem I'm having with getting my homework linked to my module is evidently Pearson's falling apart right now. So they've been very reliable. I've never had this happen during the semester, but if this lasts too long so that it push your homework back, then I'll just push the days back. Don't worry about it. If it's all corrected by tonight, then I probably won't push the due dates back. If it's all corrected sometime tomorrow, I'll push at least one day back. Okay. So yeah, there are going to be some problems. Hopefully they'll have it fixed by, time this class is over or whatever. And when I get the actual homework posted to the proper place, I will definitely email you guys and let you know, hey, the homework's now posted, because that's a helpful thing to have. All right. I got to admit, some people that got, okay. So we're back to the syllabus page. You can see there are office hours that I have. These are actual face-to-face office hours, but I can also make office hours via Zoom right before class. Sometimes I log in early enough. If someone actually needs me, I can make an appointment to log in before class and talk with you. You can stick after class to talk with me if you need. That works out as well. But if none of that can accommodate your time, and then all you have to do is just set up a meeting, set up an appointment with me, and we'll have a Zoom meeting, or you can come meet me on campus. So that's how the office hours stuff goes. There's the other shot. I know I had to change it to something else. So anybody have any questions about how you can get office hours or meetings with me? I definitely recommend you guys working together on homeworks and even practice tests to some extent. The practice test I'm going to put up usually at least a week before the actual test, and I'm going to give you a test about every 2 chapters. And those practice tests come from the bank of questions that I tend to use for the actual test. And I guarantee you that 80% of the points on the test will come from those banks. So if you were to memorize perfectly an infinity of attempts at the practice test, then you'd be guaranteed to get no less than 80 on the test. So that's reason enough for you to do it. But I'll also give you extra credit for doing it, as you'll see later. I gave you some generic guidelines regarding lab, since I'm not actually teaching your lab, but in general, don't touch the lab equipment until your instructor teaches you how, and then the instructor tells you how that you can. And then also, it's never a good idea to eat or drink in a physics lab. We got radioactive stuff in there. It's all sorts of stuff that could be bad, and so we just generally tell you not to. Some instructors are kind of cool about it, and I say cool, or will allow you to drink a drink, but just be advised, even if the instructor is nice about it, you want to definitely think about like not touching your eyes, your mouth, your nose, your face until you wash your hands out of leaving there. Okay, so that's a very important thing, and therefore I wouldn't necessarily want to eat in that kind of setting. Here's the ISBN for the package that includes the 5th edition of the textbook. This manual is what's used for the lab, but I'm not teaching the lab, so I'm erasing that from there. What you do need to have is access to the textbook, which again, if you buy the access code to the online MyLab and Mastering, it automatically comes with an e-text. And there's an app you can do for that too, so you don't actually have to go into Canvas every time. You can just use the Pearson app if you want. But that's all you need for the 5th edition. If you still want a physical textbook to read, I would recommend you buy like a 3rd or 4th edition for as cheap as you can get it. And you're not going to miss much material, because yeah, they changed it a little bit from the 4th to the 5th edition. But if you need to find out the actual specifics of what was said in the 5th edition, you can always just open up your ebook for that. So if you really want a physical copy, but you don't want to pay $200, maybe buy a 3rd edition or a 4th edition. You will need access to modified mastering physics. You'll need a ruler, a protractor, a pen, a pencil, eraser. A graph paper would be ideal. I don't require it, but I definitely recommend it. Scientific calculator, you definitely need that, and it's got to be a standalone thing. You're not going to be able to use the one on your phone or the one on your iPad or something like that. So make sure you get one. If you're not going to be a physicist or a chemist or an engineer, then you probably don't need to put a lot of money into your calculator. So just get the cheapest scientific calculator you can. If it's got a button that says SIN on it, that's probably fancy enough. If you want life to go a little easier, you might get a big screen calculator, but again, you're starting to talk about money there. Okay. The rest of the stuff is boilerplate, sort of telling you what's required and what we cover in the class. These description of the assignments, probably the most important stuff. It says each week there will be 2 or more online assigned homework assignments posted by Monday and to be completed by 11:55/11:59 p.m. on Sunday, unless otherwise specified. You should have one homework set that'll be named like chapter CH blank HW, and then there'll be conceptual questions that'll be like chapter CH blank, and then the word conceptual. Okay. Sometimes there'll be 2 or even 3 homework sets. So instead of having just chapter 1 HW, you'll have chapter 1 HW part 1, chapter 1 HW part 2, that sort of thing. So that sometimes comes up There will be online tests in which you're allowed to use your book, any other book, your notes, and Google, as long as you do not look at documents or pages created after the online test became available. And 2, you do not exceed the time allowed. The test should be 3 to 6 problems and 3 concept questions, and their due dates are showed on the schedule. Okay, so you'll see the schedule down below in a minute. There will also be a comprehensive midterm and a comprehensive final exam that will require each student to have this part's going to be a little erroneous because I corrected it, but it wouldn't save, so it doesn't have the right information. But you guys are in asynchronous. So what's going to happen here is you need to have basically a computer that you're using should have a webcam so that we can monitor you while you take your midterm. And it should have the ability to run Canvas and Canvas tests. So the practice tests are good practice for that. And it should be able to use the Respondus lockdown browser as well. I will have a practice Respondus test up before the midterm so that you can make sure all your stuff is working. But that has to be the case. If you find out that your computer just can't do it, it's not a big deal. We'll just have you'll have to go to some testing facility that can do it. If you're living near one of our campuses, you can do it for free there. If you're not, then you can find a campus near where you are and they'll do it for you for some fee. Okay. So in other words, there is absolutely a necessity for you to take a final exam and a midterm where you're going to present a photo ID next to your face so I can verify the person taking it is the person that's getting the grade. And you're going to be monitored the whole time, and that's going to count like 45% of your total grade, those 2 tests total. Okay.
I have a question.
Yes, ma'am.
So is it just the midterm and the final that's the Respondus lockdown browser?
Yeah, the other ones are really, they're supposed to be you using your resources. But
Okay.
those other 2 are ones where you don't get any resources except the equation sheet that I allow you.
Okay.
And calculator. Okay. So I will brush this up and then post it. Like I said, maybe I've got the problems fixed now. I'm not sure. It does say be prepared to let the start the test early or late or something like that. That's going to change a little bit, but basically the midterm and the final will last at least 100 or at least an hour and 20 minutes, but it might even make it longer for the final. So you need to be prepared to stay a little later on that final exam day and possibly on that midterm day, which you'll see in the schedule below. So here's the schedule. I've got a code here for the letters. I'm using the weird stuff like LD is Labor Day. Classes are the school's closed, so there's no classes on that day. But test 1, which is an online test, will be due on that day. So your class meets at 5:20 normally, so you're supposed to have it done by 5:20 on that day. Okay. It tells you basically, you can see we're going to cover about a chapter a week. So chapter 1 today and Wednesday, chapter 2 Monday and Wednesday of next week. I've actually got the list of the labs in here that you're going to do in order, but your lab instructor could change that or anything. So I'm going to take those out. In fact, I just spent the last 30 minutes erasing all those only to find out that it came back anyways. So I'm not happy. Anyways, yes, ma'am.
Did you say that there was going to be like tests that were due that we had to like take on the day of class and it would be due by 5:20, or is it just it's available earlier?
Oh yeah, so I make it available like this one that's test 1 is due on by 5:20 on 9/5. I usually make that available by no later than Thursday or Friday. And then you have Thursday, Friday, Saturday, Sunday to do it, and Monday. So it's something like that. But usually I try to leave a whole week for you to do it at your leisure. And not only that, you get multiple attempts and I only grade your highest. So those online tests are, they're made like the practice test, which you get to take an infinite number of times. And every time you take it, it's going to be different. The same thing here. Every time you take it, it'll be a little different, but you get usually 3 chances and I only take your highest score. But if you score the first time you get a grade you're happy with, you don't have to take it a second and third time. Okay. And you, like I said, the timing's kind of tight. Like I don't give you a whole lot of time, but you should be in a good enough situation where crap, there's this one problem I didn't quite understand, or didn't write down the right equation. Let me Google it real quick. And you can look that up. If you have one problem like that, you should probably still be able to fit it in the time allotted. And I don't care. That's what I want you guys to do, is figure out how to do it and get as good a grade as you can. And then just not lean too much on, Chegg and those type resources. What I was telling my students today, for instance, is I want you to make 100 on your labs. I mean, on your tests, the online tests. I would really like it on the midterms and finals. They'll be a little harder, of course, but I really want you to. And I want you to do the same thing on the online tests and the homeworks. So I encourage you to look at, for instance, My Lab and Mastering homeworks. You might be able to find them on Chegg. I encourage you to look up that kind of stuff, but do it in a very special way. So that ideally what you should do when you're doing your homework is you get a problem on My Lab and Mastering. You might want to look and say, I wonder if this one's one of the problems at the end of the chapter. So if you're in chapter 1, you look in your textbook on chapter 1 and see if any of the problems in there look like it. If it happens to be an odd one, then you can work it with the numbers that the book has. See if you get the right answer compared to the odd answer in the back of the book. Then you know how to do it, and then you can do it online and therefore get full credit. If you don't find that, then I still recommend you work the problem, do your best at getting the answer, put the answer in. If it's wrong, don't sweat it. It's not that big a deal. Google it, try to find some way to solve it. And then when you find something on the internet, for instance, that tells you how to solve it, what you want to do is say, okay, I'm looking at it. It looks like they did this, this, and this. All right, let's close that up and now let me try to solve it again. There is a creative component to solving physics problems, and I've done numerous studies, and students that just blindly copy solutions down as opposed to figuring out problems tend to do very, very badly. We basically would, when we make a homework assignment, we would put up the actual key right outside of our office when I was in grad school, and we started recording who the students were doing that. And then when we looked at their grades, those students averaged on average a low C, whereas the students that didn't come out there and copy them immediately averaged a high B or a low A. And I think what we reached the conclusion was going on was that these students were literally taking the problems and figuring out by looking at the solutions how to solve them. That's not good. You want to spend that time trying to figure out how to solve the problem and only use, help as needed. So even if you go and look up how to solve it, what you want to do is read it, try to make some sense of it, and then turn that away and try to work it again on your own. If you get to a spot you don't understand, then do it again. Go ahead and open it back up, look at the thing again, close it again, and then try to solve it again from scratch. That's the best way. So try to do that as much as you can. But like I said, I don't mind you guys getting all hundreds on your online test because you know what the right answers is. That's good, but just don't put the solution before the figuring it out. I want you to solve the problem. And then if you find you got the answer wrong, that's fine. Put the right answer in if you want to, that's okay. But learn how to do that because that problem might come up again later. Any questions on that? Okay, so I have to do that evidently because it keeps on erasing this little box otherwise. So anyways, this is the schedule. It is subject to change. I'm going to take out all the labs, but you can see, for instance, the midterm appears to be occurring on 10/19. So on that day, during your regular class time, you will not have class, but you will have a test that starts right at promptly 5:20. You will be allowed, I'll either make it for an hour and 20 minutes long, or I'll make it longer and I'll let you know ahead of time. And then again, you have another one, a final exam that occurs on 12/5. Okay. Now, what will not change is we might actually change some of these dates. Sometimes I can finish a chapter quicker than I thought, but the order of the chapters will not change. You can see I go up through chapter 11, and then I go to chapter 36, which is special relativity. And then I go to chapter 14 and 15. And then if I have time, I do 43 and maybe even 44. 43 is elementary particles, if I remember correctly, and 44 is Big Bang cosmology, that sort of stuff. So that's that schedule. Here's how the grades work. I'm on a 10-point scale, but I give you a little help to get you into the C or the D range. So instead of it being a 69.5 to get a C, you can get a 68.5 and still get a C. And instead of being a 59.5 to get a D, you can still get a 58.5 to get a C. I mean, a D, excuse me. So that's how that works. The online test, I have no idea who's taking it. You could just literally check everything and get all the answers and score perfect 100. So I can't count it for that much. But what I'm using it is the practice test is sort of like what I did when I was a student, which was our teachers didn't collect homework, didn't grade homework, didn't give us credit for homework. They just would tell us, hey, work these problems. And what I found out is that was almost never enough. So I just try to solve all the odd problems at the end of the chapter. And only when I was doing that was I making, really good grades. And it turned out the students that weren't doing that were not making good grades. So my homework assignments in my lab and mastering are not very big. But when you start taking the practice test, every time you take it, you're going to solve another problem. So you're sort of like doing the same thing as solving a bunch of problems, but you're helping yourself do well on the test because I'm using the same bank for 80% of the points at least. And two, at the end of the semester, every one of the practice tests that you took, well, actually every one of the practice test highest grades that you got will be averaged together. I'll divide that number by 20, and that many points will be added to your final course grade. So you can literally have up to 5 points added to your course grade just by doing well on those practice tests. And I sometimes have students taking the practice test literally 20 sometimes before a single test. But it only grade that counts in that is your highest score. But if you skip one, you get a 0 for that. And of course that averages with all the other ones. I don't drop any of them. So yeah, 10% on the online tests. The homework, and that's the actual problem solving homework, that's worth 20%. Your lowest 2 will be dropped, and only your lowest 1 of the online test will be dropped. Your conceptual homework, none of those are dropped, but it's only worth 5%. The midterm is worth 20%. And the finals worth 25%. The lab grade, which is normally 50% attendance and 50% lab report grade, but that's up to your lab instructor. They'll report a numerical grade to me, and that numerical grade will be worth 20% of the course grade. And you get the same grade for lab and lecture. You can't get like an A in lab and a B in lecture. Basically, they're just thrown together and the whole score is one thing. And then finally, you'll see if you add all these up, you come up to 105. That's because these 5% is extra credit for the practice tests. Now, if I assign extra credit problems throughout the semester, and I almost always do, what happens then is I'll take this lowest 2 to be dropped. If I create one extra credit problem, I will increase that number to lowest 3 will be dropped. And then I'll put a 0 in there for everybody. And anybody that does it will turn it in and I'll look at it. And if you score what I deem as an 85 or better, then I'm going to give you 100 for that extra credit. So it just basically erases your lowest grade and replaces it with a 100. If you don't score an 85 or better, I'll either leave it as a 0 or I'll give you some hints on what to do and allow you to resubmit. And then you might be able to get your 100. Okay. So that's how extra credit works. You'll be able to find it through SIS at the end of the semester. Basically, if you miss 2 labs in a row or 4 class meetings in a row, I can drop you, and they try to get me to drop you. If you actually have to miss them and you know you're going to miss them, let me know and I'll work with you. But the main thing is missing class can result in a drop. If you miss a test, if you miss the midterm or the final and don't contact me really, really soon, you're probably going to be dropped. Okay, so I don't want to do that, but that's what we're going to have to do. Also, if you do decide that you think you want to drop the class, first talk to me. It's very rare that I recommend a student to drop, and I can almost always figure out a way to help them so they can still succeed. So keep that in mind if you do consider dropping. And then if you also consider dropping, make sure you finish the process. I've had numerous students tell me they're going to drop, and then come the end of the semester, they never put in a drop. So I have to put them in as dropped, and they get an F because it's after October 24th. So you just ruined your GPA. You might have got in trouble with the GI Bill or whoever's paying your tuition or financial aid. There's all sorts of stuff you can get messed up by taking that F. So don't do that. Make sure you finish it if you do decide to drop. But again, talk to me first. October 24th is the date after which nothing can be given to you but an F. Let's see. That's supposed to be 24 there, so I'll put that in. I've never really had a problem with students misbehaving, but there's a generic solution. Your homework, you are allowed to turn it in up to a 1 week late, but there's a penalty, point penalty. So you prefer not to do that. The test you can't really do late. The midterm and final you can't do late. So make sure you don't do that. You'll see there's some pretty strict rules. Basically, if something happens that you actually have to miss the midterm or the final, you or someone that represents you should contact me within 48 hours. And then I'll either give you an incomplete for the course and let you make it up later. Or if we still got plenty of time left or something, I'll go ahead and, so if you're okay, go ahead and give it to you the next day. I'll just have to make a different test because obviously you might have heard what was on it and had an unfair advantage. I say face-to-face test. That's not going to be part of this. That's just because it didn't save all the work I did. So we'll correct that later. That's pretty much the important stuff about the syllabus. Anybody have any questions about that before I close up the syllabus?
Actually, in regards to some of the homework and testing, is everything going to be on Pearson to be able to pull that through, or is it going to be separated?
Okay. That's a good point. Let me go ahead and kill this so you can see. I'm going to share screen now, but this time I'm going to share it with our Canvas page, which is right here. So what's going to happen is every week you'll have a week module. So there's week 1 module, for instance. This will be where there's a ton of videos that I made on my YouTube channel of me solving physics problems, of me giving actual lectures. So if you miss a lecture, you can find one there. I've got more stuff than really necessary. I'm going to try to wean some of that down this semester. But the main thing is you just got a buttload of stuff here that you can look at. So all those videos will be here. Down here at the bottom, there will be a link to chapter 1 homework sets. So that'll be through Canvas. And everything that you're doing in Pearson, you're still going through Canvas through. So in fact, the only place you're going for any work is really Canvas. Okay.
So right now on my screen, at least, I don't know if it's anyone else, but when I go to my lab and mastering, it just gives me a support ticket. It doesn't give me the access to actually get into it.
Oh, it's like when you click this over here, my lab and mastering.
Yeah, it just gives me a support thing. It doesn't give me an access to get from there to Pearson.
Yeah, that will eventually be fixed. I think that's the problem they're having with Pearson right now. I'm curious what it does when I hit it. Let me see real quick. Yeah, it gives me this, and I've been trying it all day. And actually, I tried it even yesterday. And I
Yeah, that's what we get.
So what I'm supposed to do is go here, click on this, and then I can link my course up to it. But I've been unsuccessful at that so far. As soon as I get that done, if it's not done by tonight, I'm going to push I'll push your deadline back at least a day. Okay, so don't fret it too much on that. The homework due dates will always show on the homework system as well as through Canvas. But yeah, everything you're doing this semester, including your lab work, well, actually not including your lab work, since you have a different lab instructor, everything but your lab will be done on this Canvas page. Your instructor for lab may or may not choose to use Canvas for your labs. Okay, so if I make up an extra credit assignment, what will happen is if I made it for this week, it'd be down in here and it'll just say extra credit, and you click on it and it'll have a place where you can turn in a PDF. I generally only accept PDFs. So if you work it out by hand, that's fine. Try to write it nice and neatly, take a photograph of it, email that to yourself, then take a Word document, maybe change the borders, the boundaries to 0 or a 1/2 inch or something like that, and then insert the photo and then save that as a PDF and upload that. That's pretty much how you turn everything in. Just because PDFs are less likely to have viruses in them, people can still do it, but a lot of people do it to Microsoft products. So I do everything in PDFs. What you'll also notice here on this page is I have this, that's my YouTube channel. I have not monetized it. I'm not making any money off you guys, but it would be nice if you subscribe to it. Nice for me, but more specifically, I'm meaning it would be nice because every time I put up a new video, if you're a subscriber, you'll get an email or an announcement that I just put up a new video, and you can usually tell by the title whether it's relevant to your class or one of my other ones. It's www.youtube.com/Billy Younger Physics Solutions, and the first letter of B of Billy and Younger and Physics and Solutions are all capital. That's my YouTube channel. It has a ton of stuff for astronomy, physics, math. Eventually it's going to have engineering stuff. I have some statics and dynamic stuff there. I actually have some actual engineering calculations that'll be put up there. I'll do some chemistry. Not only that, you also have access to this Google Docs. So if you look in my Physics Solutions YouTube channel, you'll see that some of the video quality is really bad because we had bad bandwidth and stuff like that, but the words are all still good. So I also didn't have access to anything where I could write nice other than writing directly on paper with a camera. So what I've done is every time I made one of those videos, I took photographs of the actual notes that I was taking and I put them on here. And when you look at the video, it will have a name like PHY241, and then it'll have like a date. You just look for that name date in the Google Docs, and that'll be the actual document that you need to go with it if you find one you want to watch. I don't recommend watching whole lectures, at least not in one sitting. You know, maybe do 10, 15-minute intervals at a time. Probably the better ones are just short videos of solving individual problems. But that's available to you. This is a list. It's kind of old. I need to make a new one, but that's a list of the titles of the videos that I have on there. You can see this is practice test 1, so that's ready to go. If you're wanting practice on chapters 1 and 2, you can start doing that immediately. That is probably better even than the actual homework system. But in here on week 1, you'll have down at the bottom, there'll be a chapter 1 conceptual and a chapter 1 homework that'll be there. And when that is posted and working properly, I'll email all you guys to let you know. You can see next week we'll have another week. Notice that's not showing because I haven't published it yet. So everything that you do will be done through Canvas, including your Pearson stuff. So any questions on that? All right, well, we've got about 30 minutes left, and I've now finished basically discussing your syllabus. I don't have much time to get into everything, but what I will tell you is some of these videos are actually very helpful. For instance, we assume when you come into class that you know a little bit about the scientific method already, but more specifically that you know scientific notation. So you know how to write numbers as 8.32 times 10 to the 5th, that sort of thing. If you don't, here's a video, scientific method and scientific notation. That's a useful video, okay? If you're rusty on scientific notation, that's a good place. It also has a discussion of the scientific method as I explain it, which I'm going to do for you guys in a second. I also have a big part of physics is converting units. There's a lot of different unit systems in the world, and we need to be able to convert back and forth between those unit systems and as well within our own SI system that we use. So this is a nice video on how to do that. Believe it or not, Sig Figs are like not something people use. Science is not done with Sig Figs, but it's a first order approximation to how to do science. So we sort of use it when we're doing our homeworks and when we're doing problems from the textbook. So here's a video on Sig Figs. Here's a PDF where I tell you the Sig Fig rules and how to use them. And then here's a video where I show you using them and showing you a case where it fails. That's why real scientists don't generally use Sig Figs. Okay, they use something called propagation of error, and we will have some discussion of that throughout the semester. Right here, this is Sig Figs, scientific notation, unit and dimensions. So this is essentially a lecture of all of chapter 1. So that's a nice thing to watch. If you don't understand something I said today or next time, I would recommend watching that. And you can watch it, pause it as often as you want or whatever. That's kind of nice. The rest of these are all just old lectures. And again, I wouldn't say they're necessarily that great, but these ones that I pointed out, those are pretty good. So it's worthwhile if you want to check them out, or if you just don't understand something, need it to be reiterated to you or re-explained, that's a good place for it. This is what a typical homework, extra credit homework will look like, but it'll have like an assignment link so you can click on it and turn it in. Notice this one isn't active. That's why it's not published, so you won't see it on your side. So that's what those videos are about. And every week I will have links to videos. Sometimes they're demonstrations, but usually they're links to specific problem solving events that are problem solving videos that I made or something like that. But again, you can also just go to my YouTube channel and look for things by doing searches within that page. Now, this week we're supposed to cover chapter 1. So I'm going to start off by discussing, first I'm going to kill this. We're going to discuss my version of the scientific method. And probably you recall from grade school, there was always some banner up on the wall and it says you do this and then you do this and you do this and do this and do that. And that was the scientific method, right? That was pretty much made up by book publishers, and it's sort of a hodgepodge of all the different things that people do at different points, but not necessarily ever in that order. In fact, the scientific method can be quite different from one problem to another. So I'm going to give you a description of it that's quite different from what you're used to. So what I'm going to do is I am going to turn on my iPad and use it if I can. Let's see here. I think I use GoodNotes, and I am going to create one. And the title is going to be PHY 241 N01B, and then I'm going to do underscore 082222. Okay, so notice that filing, that naming system that I just gave you was PHY 241 N01B. Your class is called D02B. It's not supposed to be. So I'm calling it N01B in hopes that it will be changed properly. Now what I'm going to do is I'm going to try to share this with you guys. And the way I do that is I do share screen. And I'll say iPad or iPhone via AirPlay. And now I'm going to, oh, didn't mean to do that. So let's go here. I'm going to share my screen. I got to do screen mirroring. It's not letting me for some reason. Let's try this. There it is. Okay, so maybe it's not working. All of a sudden it just stopped working. It was working beautifully and now not so much. Man, it's just not letting me do it. That's weird. Let's do stop share. Now I'm gonna try it again, see if it works this time. Screen share. Got that. Let's do share. Now I'm gonna do screen sharing. It just won't connect. Oh, well, I guess we're gonna have to go with a different method, which is not necessarily fun, but it can be done anyways. So the scientific method that I'd like you to think in terms of allows us to define phrases like theory, hypothesis, prediction, all that good stuff, models, so on and so forth. And it looks like this isn't going to be able to come on the screen either, so that's not very helpful at all. But here's what I sort of, dang, this is terrible. What I sort of think of it is you can observe or you can run an experiment. And I'm sorry, this is just going to have to be the way it is. But luckily, it's nothing where I'm actually solving any problems right now. So that's not going to be very hard. But what I think of is this top is like you observe something or you do some kind of experiment. That's not always how science starts. In fact, I'm going to tell you that relativity started an entirely different way. But right now you can imagine, say, I look out in the front yard and I see a small kid and they sort of with a straight arm just throw a ball. And all of a sudden I notice, hey, that's kind of neat. The ball makes this little path that looked like a quarter of a circle. Now, if you know anything about physics, you already know that shape is wrong, but don't worry about that. It doesn't matter if your idea is wrong or if your idea is even realistic. All that matters is you have some way of describing what you saw that you can test in a falsifiable way. So you might say, okay, well, that did look like a quarter of a circle. So maybe I could make the hypothesis that when kids throw balls, the balls trace out a path that is basically 1/4 or 1 fraction of a circle. And of course, if you throw it like this from straight up, then it's going to go horizontally down to vertically. And of course, that would be exactly a quarter circle. But if you throw further ahead like this and release the ball when your arm's out like that, then it might do, say, 3/8 of a circle or something like that. So the next step beyond the observation / experiment is you're going to make a hypothesis / model. So the top step is observe / experiment, and then an arrow points down from it to hypothesis / model. That's the diagram I would draw if I had my iPad working right now. Now, what does that mean? That hypothesis or model can be completely fake. It can be I believe there's a gremlin in the car and it's doing A, B, and C. It doesn't matter. You can actually make this stuff up all the time. And actually people have found where very absurd things have turned out to be pretty good explanations. So our hypothesis / model would be, we're pretending the path or trajectory of a ball thrown by a child is a fraction of a circle. And we might say, I believe it is, in fact, if the kid releases the thing perfectly horizontally over his head, I believe that it will trace out a circle, and the radius of that circle is exactly equal to the height from the ground up to where the ball is released. Okay. So now I've not only made a hypothesis, I've incorporated a sort of mathematical model. We know, for instance, the equation of a circle is parenthesis x minus h squared plus parenthesis y minus k squared is equal to r squared. So that's a very definitive thing we can look at. Now we can take that and make a prediction. We can say, oh, look, this kid right here who's 3'8" and has an arm that extends higher than his head by 12 inches, is going to throw a ball and is going to land a very specific distance away and follow a very specific circle. And if it doesn't, then the hypothesis has failed. Okay. It's falsified. If it does, the hypothesis is right. So I now have a falsifiable prediction, and that's the next spot. So the first spot was observe / experiment, and then an arrow drawn to it, from it to hypothesis / model, then an arrow drawn from it to prediction. Okay, and that prediction has to be falsifiable. You don't have to have the ability to prove it right. You only have to have the ability to prove it wrong. That's what makes it a scientific hypothesis. Okay, now from that prediction bubble, there will be an arrow that goes from it back to the observation bubble. So that's our diagram. 3 little bubbles: observe, experiment, hypothesis, model, prediction, and they're connected in a cyclic way. Now, you should have the caveat that that prediction has to be falsifiable. So for instance, one of the typical questions we ask in our conceptual physics class is, we'll give all these very scientific sounding hypotheses, using fancy words and all that stuff. And then we'll have one little hypothesis that says the moon is made of cheese. And lo and behold, every one of those very sciencey sounding hypotheses are non-falsifiable and therefore non-scientific hypotheses. But claiming the moon is made of cheese is a falsifiable hypothesis. All we have to do is we could, for instance, measure it geometrically from here, measure its weight from studying gravity, calculate the density. If the density doesn't match that of cheese, we know it's not cheese. Or we could actually fly a spacecraft up there, pull up a chunk, bite it. If it didn't taste like cheese, it's not cheese. Okay, so that is an actual falsifiable hypothesis. That's the main thing you got to remember about that. Carl Sagan in Demon Haunted World, Science is a Candle in the Dark, uses the idea of a young boy telling you, I've got a dragon in my basement. And Carl Sagan would reply with, oh, wow, I'd really like to see that. Can I see your dragon? Oh, no, it's invisible. Oh, well, that's okay. I don't mind that. But maybe I can just spray some baby powder all over the floor and then I can see his footprints. And he'll say, oh, well, no, the dragon floats above the ground. He flies, basically. So you can't do that. And then Carl Sagan responds, well, that's okay. What I'll do is I'll just take a little smoke or fog machine in there, and I'll just fill the room up with smoke and fog. And then I can see his outline as he flies through the room. And the boy says, oh, no, he's immiscible. So like stuff goes right through him. You get the feeling that everything you offer to do to see the dragon is going to be told, you're going to be told some reason why you can't see the dragon that way, right? That's what we call a non-falsifiable hypothesis. And there's nothing wrong with non-falsifiable hypotheses. They're just not science, okay? They just can't be science. It's not scientific unless there's a way to prove it wrong, okay? So once you go with whatever, oh yeah, that is a great book. But anyways, once you go through that process with some model, whether it be, the quarter of a circle hypothesis or whatever, once you go through that cycle over and over and over again from observe, hypothesize, predict, observe, hypothesize, predict, observe, go around that hundreds of thousands of times, if you are actually explaining one thing very narrow, you are building a theory. And if you've never, ever, 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 ever been found to be wrong in all those trials around, you can start to call it a theory. A theory is a strong word. You shouldn't use diminutive adjectives in front of it like just a theory, okay? This is science trying to reclaim the word theory so that you guys understand the difference between it and the old use of the word theory. Well, it's just a theory, okay? The general theory of relativity is no longer just a theory. It is actually a really powerful, well-tested, well-observed theory, and that is a strong word. Special theory of relativity, probably the single most tested theory in the history of mankind. It is a viable theory. It's as close as we come to quote unquote a law as possible. The big thing to remember is nothing ever has the actual classification of a law in the sense that you're probably thinking. If we ever came up with a theory that we trusted so much that we'd say the experiment was bad if it was wrong, then we would be basically experimenting with dogma as opposed to science. So the way Einstein put it is, no number of experiments will prove me right, and it only takes one experiment to prove me wrong. And that's absolutely right. If we find one thing that Einstein's general theory of relativity is wrong about, then we either have to fix that or we have to throw the whole theory away. Same thing with the special theory of relativity. Same thing with the theory of evolution. Same thing with the Big Bang theory. Now, things that we call laws are often just things that are observed, like if you're a scuba diver, you know, Boyle's law, pressure and volume are inversely related. That's a law in the sense that every time we do that experiment, if we decrease the pressure, we increase the volume, or vice versa. But it has no more strength than the word theory. It might be, someone might ultimately start calling the general theory of relativity the general law of relativity, but it still only takes one experiment to overturn it. And that is tough for science, but that makes it strong. That means we're never going to do what the ancients did. We're never going to say Aristotle just can't be questioned because he was the most brilliant person ever. And we're not going to trust it if experiment says otherwise. Okay. So that is a more modern idea of what the scientific method is. And the more and more you go around that, the more confident you get. If the thing is more widespread than just explaining, for instance, balls thrown by kids, then you're more likely to have it make a classification of a theory in the big paradigm sense, meaning Newton's laws of motion are really Newton's theory of motion. And they're a whole framework or a paradigm about how you solve problems. And that's what we're going to learn in this semester, is basically Newtonian physics. It's, even though we call it Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, really the whole paradigm is just Newton's theory. And what happened when we came up with quantum mechanics was that we came up with something called a correspondence principle. A guy by the name of Niels Bohr did that. And that aids us in finding future theories, such that if we ever find something that we think is better than Newton's laws, like we did in relativity and general relativity, that's fine. But since Newton's laws, quote unquote, Newton's theory, works so well in certain areas, then this new theory, Einstein's special theory of relativity or Einstein's general theory of relativity, must in fact reproduce Newton's laws of motion in the realm where Newton's laws of motion worked well. And in fact, they do. You can take the limit as v goes to 0, and the equations from Einstein's special and general theories of relativity, taking in small mass and low speeds, they actually reduce to the equations of Newton. So that's the modern way science works. And as I said, it doesn't always start with an observation. In the case of Einstein, Einstein was looking at Maxwell's equations, and because Maxwell's equations do not allow for different speeds of light, it turns out Maxwell's equations are already correct for special relativity, and Einstein was the only person brilliant enough to see that that was causing problems in nature. So he basically solved a problem that not only did no one else could solve, but in fact, he solved a problem that no one even knew existed. By looking at Maxwell's equation, he could see paradoxes that didn't make sense to him. And the only way he could make sense of it was to assume that the speed of light is a constant, and it doesn't change just because the source of the light is moving fast towards you or away from you, or you, which are detecting the light, are moving fast towards it or away from it. The speed of light is a constant independent of the motion of the source of the observer. That's what Maxwell's equations were telling him was true. And that was one of his principles of relativity. The other one was the laws of physics are the same for all inertial observers. And that inertial thing just allowed him to ignore gravity. Now, he therefore started from the hypothesis phase of the experiment instead of the observation. There had been no observations made. He just made up what he called a Gedanken, which is a thought experiment. He made up a thought experiment that led him to conclude something. And from that, we got the fact that time slows down when you're moving fast. So if I see you flying down my road at 3/4 the speed of light, and I look on your watch, the second hand's going to be moving very, very slowly. But get this, if you look back at me as you're flying by, in your frame, I'm flying by that way, and you're saying my second hand's moving slowly, and we're both right. Not only that, if you're like in a dragster going down my street at 3/4 the speed of light, you know, dragster with the big wheels in the back and the small wheels up front, and they're really, really long. Well, that dragster is going to shrink really parallel to the velocity to be very, very small. So I'll see a dragster that looks more like a Volkswagen Beetle flying down the road, but you looking at me will say, wow, that dude's got a really narrow house as you ride by me, because my house is going to be contracted the same way your dragster was contracted. And again, we're both right. Okay. So that's what Newton didn't see, and what Einstein was able to see was that the laws of physics are really weird, and they're tied in with the speed of light in a very coherent way. Now, a lot of people thought he was a nut as soon as he published it. And in fact, he didn't win the Nobel Prize for that. He won the Nobel Prize for his work on quantum mechanics, which he totally went to his deathbed not believing. But eventually it turned out that we've now done more experiments on the special theory of relativity than any other theory in history. And it turns out that the special theory of relativity is 100% almost completely done, meaning the first thing we do, even though it's not technically true, if we find someone finds a violation of special theory of relativity, it's much more likely that we're going to ultimately figure out that the person did the experiment wrong. That being said, we still check, okay, because we can't fall into dogma. And that's the big picture of the scientific method. So I'm going to call it. We're about 5 minutes early for finishing, and that's just fine. I've got your roll based on your attendance here. Just keep that in mind, that how that scientific method works. It's going to read a little different from your textbook. When you're answering questions on the homework, pay more attention to the way the textbook tells you. That's more important. And you'll see as the semester goes, this class will be a lot of fun. I will finish all of chapter 1 next time, but you can get a little head start if you want to by looking at those YouTube videos. So have a good day, everybody. I'll wait for the last person to leave in case you have any questions. And thanks for coming.
Thank you. Have a good day.
You too.
I have a question in regards to, I guess, your professional opinion.
Okay, go for it, Bianca.
So I technically already took physics 1 and 2, general college physics.
Okay, like the
And
yeah.
And by the time I got to my advisor at ODU, I'm going for the CET, Civil Engineering
I'm going to
Technology.
stop recording this right now because
Okay.
it might tell me personal information that I don't want on the internet.